Hello everyone, welcome back to our next session in Core Python playlist. In previous session, we have talked about advanced data types in Python, and the first advanced data type that we have seen was list, right? So in this video, I'll be talking about different functions which are available in list. So let me quickly tell you how a list is defined. So list is denoted by the square brackets, right? Let me just enlarge it a bit for you. And if you see, what you have to do is you can store any type of data. So list is heterogeneous in nature. And second thing about list is it's mutable, right? So once you create the list, you can modify the list. Whereas we have talked about tuple. Tuple is same as that of list, except for two things. It is denoted by round brackets, and second thing is it is immutable. Once it is defined, you cannot modify the list. You cannot modify the tuple, basically. All right, so this is how you can define any list. So I'm just going with like the name of the list I've taken as Lee, and I have given all integer number. Okay, just to have a clear understanding about these functions, I've taken it. Okay, so you can see, if you are able to recall, I have explained you about the concept of indexing as well. So indexing starts from 0 from left hand side. So 12 will get 0 indexing, there's the first element. Then 45 will get 1, then 2, then 3, and then 4, right? And from right hand side also, we got one more indexing called negative indexing. So 76 got 2 indexing, a positive indexing, and a negative indexing, that is -1. All right, so let me just quickly show you once again, like what if you are putting up like this, like for example Lee of 4, it is showing you 76, right? Because here it's 0 and 76 got 4 index. Similarly, if you're just going with Lee of -1, it is still showing you 76, because we are now accessing 76 through negative indexing. All right, so let me just show you now the different list functions which are available. But there are a lot of functions available, guys, and that's the beauty of using the inbuilt data types of Python. You will get lot of inbuilt functions along with the advanced data type. So there are few general and the common one, like len. Len is of the list, not of list, but like it's a general Python function, to which if you pass any like iterable, it will return you the length of it. So we will be using like len to find the length of your string. Len simply means number of elements inside the list. It will be giving you that. All right, so then there's something called as append, insert, remove, pop, index, count, and sort. We'll see them one by one. All right, so let's start with our first one, that is len. So in this case, you can see I'm just passing on Lee to my len function, and if you just click on, if you just execute it, it's showing you 5. That is total number of elements that are present in list. So that's what len is used for. All right, so the simple one, and then we have append and insert. Let's talk about that. Like for example, now you want to add one element at the end of the list. All right, so for that you can use append function. Okay, so one more thing that I wanted to show you is, every time you write like you want to call in any function, you won't write the complete name of that function. If you're using Jupyter notebook, so what you have to do is just write initials of the function and just press tab. Okay, like here we just have one function with append app, and if I'm just going with a, and like even if I'm pressing tab, I'm getting that append. Okay, so if you see lee.append, I'll be calling append function on Lee. And now whatever I want to add, like for example I want to add 99 at the end, so I will write like this, lee.append. I will pass this number to it and just press just execute it, and let's just print Lee, and you can see that 99 is attached or appended to your list. And the thing about append is it will append at the end only. Okay, so you got one more index now, and that is your last index, and -1 will be to 99 now, and 76 will get -2 now. All right, so that was about your append function. The next function is, let me just keep writing in comment as well. You guys also make a habit of writing comments, like whenever you're writing code, comment will remind you of what you have exactly done in that code. Okay, so we have implemented the append function, so let me just write append function. All right, so now let's just go with our next function, that is our insert function. As the name suggests, guys, it's again used to add a new element to the list, but as we say, append will append at the end, whereas insert, we can insert at any particular index in the list. All right, so let's see how to do that. So if you see, again, I'm just typing in, I'm pressing tab and showing me index and insert. Okay, there are two functions with in initials, so I'm going with insert right now. So insert function takes two things, guys. Okay, one thing is it takes the index at which you want to pass the you want to add the value at. Okay, so for example, I want to add at index 3, and I want to add, for example, I want to add 78. Okay, so you have to do like this. You just have to write like this and press shift enter. All right, and let's just check Lee now, and now you can see at index 3 78 is added. Initially you can see at index 323 was there, right? So you can see at in between 56 and 23, that 78 new element is being added. You can see, so after 73 all number will get a new indexes, right? Because 78 got 3, so 23 will get 4, 5, 6 likewise. So this is what insert function is. Okay, so generally student ask me this, like if you're calling up in the insert function, and if you're passing, like we are saying 100th index, add up, for example, add up 200. Oh, I don't want to confuse you, let's just go with some smaller number. For example, I want to add 13, but at what, at 100 index, right? So will it give error? Because we don't have 100 error, right? 100 index, right? So Python won't give you error. Python will simply add up at the end. Can you see here 13 is added at the end? So you gave index according to wherever you want to insert, but if you're exceeding the last index, so it will simply add up to the last index. It won't give you error like add index out of bound, that sort of error we used to get into other languages, right? So that's it, that's for the insert function. I hope you understood. You can add up any element. And then we have remove, pop. Let's talk about these two. So if you want to remove, let me just show you remove function. If you want to remove any particular number from the list, so you can just call up remove function and pass on the number that you want to delete from the list. So for example, if I want to delete 56 in this case, all right, so you can see again I'm printing list, so boom, 56 is gone from the list because we have removed it. All right, but I want you to understand one important concept here. Lead.append, for example, I'm calling up append function again, and let me just take one more variable, 99 for example. Okay, or let's just go with 12 in the case, right? So I have added 12, so we got two 12s now, right? 12 and 12 here as well. Now let's just call up remove function, and I'm asking my remove function to delete 12. All right, so 12 is deleted from the list, but let's see now, understand this concept that 12 is deleted from the first occurrence. The 12 that we have added up later on is not deleted, because remove function will remove only first occurrence from left hand side, okay, from the 0th index, where as soon as it receive it got 12, it will give you, I mean, it will remove that and won't touch any other duplicate value of 12. Is that clear? Yeah, if you call a lead or remove for the second time, this 12 will also be removed. Is that clear? So let me just show you that as well. Or we can call it 2 times, and now let's just check Lee. You can see 12 is gone. Now what if I call this again and pass up 12? So this will give me an error clearly telling me that X not in list. So you said 12 instead of X, so it clearly mentioned you that 12 is not in the list, so I can't remove it. So that's what we got. So that's what list we have right now. Let me remove this, and let me just show you about the next function, that is pop. Okay, again, I forgot to list out the function here, that is remove function. All right, and now pop function, let's just comment here and All right, so now see guys, okay, let me just print the Lee. So this is our Lee right now. And what if I call pop function? Let's see what difference it makes. So we see Lee.pop will pop out the last element from the list, okay? And if you see now, Lee does not have 13, right? So you can see pop will pop out the last digit from left hand side, okay? I mean, if you're just counting from the positive index, so the last element is this, that will be removed, okay? But we can remove any specific index as well. Now if I write, okay, let's just concentrate here. Now we have, this is our latest list, so I'm calling a pop function again on this. All right, pop, and now for example I'm telling it to remove 2. So can you see this, what it has done? Oh, sorry, let me just show you a list again. Right now the list is 45, 78, 99. I have, I mean, executed it twice. And now for example, if I'm saying lead dot pop 1, okay, this is our list, and I'm saying lead dot pop, and you can see it has deleted the element at index 1. 0 got 45 got 0 index, 78 got the second index. And if you print Lee now, you can see 45 and 99. That's what you have right now, okay? What happened was I executed it thrice, so for that reason the values, I mean pop just cut out index 1 3 times, okay? So I hope you got it. So Lee.pop will remove the last element, but if you are giving any specific index, that particular index will be removed from the list, okay? And one more thing, important thing that you will encounter a lot of time, guys, I want you to be very clear with. Can you see this in, and you're getting this into square bracket, the numbering, right? So this numbering are not the numbering of the line, the numbering of the execution. There's a timestamp of, I mean, not a timestamp, the number stamp of execution. So 94, 96, that's how you have executed this program, okay? So if I execute one more time this particular line, you can see I'm just going up again the first line. So if I run this, you can see 121 time this is what we have executed. And if you print the list, okay, if you print the list, now you will get the, because that was the last code that we have executed, and now you can see 122 is what we have executed this. All right, so while executing things into Jupyter and Colab, remember the execution does not depend on the line by line process. I mean, it's not top down, okay? If you're going and saying, okay, so just go to kernel and run all, okay, for example you're saying restart and run all, so it will start from the first index and will come to the last cell, okay, first cell to the last cell. But yeah, you can go to any of the cell and run it, and that series, that order will be followed, like the way we have done it right now. At 121 we have executed this, and at 122 we have executed this, okay? So all right, we got a new we got a list back. What else we are remaining with? Let me just check. Index, count, and sort, okay? So let's just see with our index first. So as the name suggests, again, it will return the index of the particular element. So let me just again do lead dot, just call up the index function, and I'm asking it to give me what is the index of 56. Okay, so it will return me the first occurrence. Always remember, if you have 256 into your list, it will return the index of the first occurrence from left hand side. So 12 got 0, then 1, and then 2. 56 got the second index, so it's just giving us the index of 56. All right, so this is what index function is. And then we got count function, an important one for us. All right, as the name suggests, it will count number of occurrences of any particular number that you're having. Like for example, we don't have any repeated, so we will append few numbers so that we can get the value of count to be more than 1. So in this case, let's just say I'm saying, okay, Lee count 23. So it will count how many times 23 occurred into the list. Okay. So of course, into the list, it's repeated only once. And what if I say 99? So it should give me 0 answer because 99 is not occurred even a single time into my list. Okay. So for this, let me just show you one important thing here, guys. Lee dot, for example, I'm again calling up append function, and let me just add, sorry, 23, and let me just copy paste this again. I want to add 23 two times. So you can see now we have 323 inside our list. So now let's just count 23 and check whether we are getting 3 or not. So you can see it has counted the 23 number into the list, and it found that it occurred 3 times, and that's what we're getting into the count. I hope you got it right. So that is what count function is. Now the last function, the important one again, the sort function. So let me show you. As the name suggests, again, the function names are according to its name, it's working, guys. So it is super easy for you guys to remember the function names, and if you come across any function name, you will be in a position to clearly tell what exactly the function is doing. Okay, all right. So now if you see our, let me just print the list here. Okay, this is what our list looks like, right? It's unarranged, it's not sorted, right? So let's just call up lee.sort, and you can see now the list is sorted in ascending order. That's by default. 12, 23, 23, 23, we have 323, 45, 56, and 76. All right, then one more thing that you need to, like, for example, I want to arrange them into descending order. So there is a a parameter into sort function, that is reverse. We just need to make it true. Now if you see, Lee will be sorted in descending order. All right, 76 is first, and the 12 got the last element. All right, guys, so this is what sort function is. Now, important thing about sort function I want you to be very clear with, it works only good with if you have all numeric values or all string values. Now for this case, you can see what we have is Amir is added up. Now I'm trying to sort this, so this will give me an error clearly telling me that not supported between instance of string and int. All right, so for this, the data has to be homogeneous. Either you can have numeric value, all numeric values, or string values. Okay, so if you have numeric value, ascending order simply means lower value to the higher value, whereas if you have all string into the list, it will sort out the list on the basis of alphabetical order. All right, but yeah, if you have a case where you can see it here, your list has numeric value as well as string value, now it won't be able to sort it, right? Logically it's impossible for you to sort. You can't have any preference of having string or integer or numeric value first, right? So for that reason, clearly says you can use sort, but on homogeneous data if you have in the list only. All right, guys, so these were the common functions that we will be using a lot of time in the list, but apart from it, there are other functions as well. Like we will be, as and when required, I'll be telling you about that. One more thing, into the next session, we'll be talking about slicing, one of the very important concepts that we'll be using into machine learning and other places as well. Okay, so that's it for this session. Let's meet in the next session. Thank you.